Hey, physics fam, we are looking at the back page of the speed, velocity, acceleration mashup practice. This is a great review for if you have an upcoming quiz or anything like that. This is the conceptual side of things that is important to know, not just solving the math problems. So let's look at the first question that we have up here. So number 5 is match the description of the object's motion with the letter of one of the 3 graphs below. So is it going to fall under the motion of letter A graphs, B graphs, or C graphs? Something to notice. This is a position versus time graph. This is a velocity versus time graph. And this is an acceleration versus time graph. So this all represents the same type of motion. These all represent the same type of motion. These all represent the same type of motion. So let's match A, B, or C with the group. So let's look at the first example. 2 people are enjoying the view as they constantly move on a ski lift. So let's think about that. When you're constantly moving on a ski lift, that means you're going to have a nice constant velocity moving forward. So which one of these graphs would show a constant velocity? Well, first of all, if we look at a velocity time graph, a constant velocity should show a nice flat line. So I see that constant velocity right there. What does that look like in an acceleration versus time graph? Well, if you're a constant velocity, you're not changing velocity. So technically your acceleration is 0. But also, if you're moving at constant velocity, every amount of time you travel the same distance. So that looks like letter B is the best example for this one. If we look at the next one, let me get a new color. A bunch of bananas sit on a counter and slowly begin to ripen. Are those bananas moving at all? No, they're just sitting there. So, from a position point of view, is the position changing? No, not at all. So this would be an example where position is not moving. It's just staying the same. That could be the banana sitting there. Also, if you're not moving, you have no velocity. That's why this velocity time graph is 0. And of course, if you're not changing velocity, you're not moving, you have no acceleration, which is why it's 0 as well. So for this one, A seems to be the best choice. Now, before you go skipping and put, oh, yeah, I know. Okay, great. Then this must be C. And it is, but let's make sure we understand why. A mouse sleeping probably not moving, is frightened by a cat and quickly runs away. So if you are starting at 0 velocity, not moving, your final velocity must be something bigger than that. So I don't know, let's say 10 meters per second. You went from 0 to 10 meters per second. You must have had an increase in velocity. So that would definitely show right here is this example. Your velocity started at 0 and increased and increased and increased over time. So this is a great way of explaining the mouse starting at 0, sleeping, and then speeding up in the position versus time graph. So that's why C works there. We now jump down to number 6. The hint here is that when an object decelerates, the velocity and acceleration are in opposite directions. So that means if we're slowing down, if velocity is forward, acceleration is backwards. If velocity is backwards, acceleration has to be forwards in order for you to decelerate or slow down. So if you're slowing down, acceleration is opposite your direction. If you're speeding up, acceleration is in the same direction. So let's look at letter A. If an object is speeding up towards the east, so first of all, this object is getting faster and it's moving towards the east, then what direction would the acceleration be? Since we're speeding up, acceleration has to be in the same direction. So that must mean that acceleration is going to the east as well. How about letter B? An object is slowing down towards the north. So it's headed north and it's slowing down. So what direction must acceleration be? If you're slowing down, acceleration has to be the opposite. So if this object's moving to the north, acceleration is moving to the south. For letter C, if an object is slowing down in a forward motion, so it's slowing down, so that means acceleration has to be opposite of it. So if it's slowing down and it's moving in the forward direction, then the acceleration has to be in the backwards direction. Sorry, I have to squeeze that in there. Backwards is what acceleration would be. How about the object speeding up towards the south? If I'm speeding up, acceleration is in the same direction. So if the object's moving south, so should acceleration. All right, so think of it this way. If an object's going to speed up, acceleration helps. So if your velocity is forward, acceleration will be forward as well. That's speeding up. If your object was slowing down, though, and you were moving forward with velocity, acceleration would have to be the opposite direction to slow down, or what we call decelerate. All right, physics fam, hopefully that helped out on the back page a little bit, and keep on studying and be prepared to ask questions in class. Let me know what you need. Happy to support. Be well.